Who here works with C#? Raise a hand. Yay, good. The abstract worked. Great. So F# is a valid alternative to C#. And considering the fantastic interoperability between the two languages, it's also valid as a tool to use in addition to C#. And that's why you have to know the pros and cons of F#, because if you're not gonna take a look at F#, someone else in your organization is, so you probably want to participate in that discussion, or at least have an opinion. And I'm gonna show you the pros and the cons using real examples as the backdrop. Now 20 minutes is not a lot of time, so suddenly I started talking a bit faster, remembering that. So it's certainly not enough to learn a programming language. So I'm not going to learn you F# in these 20 minutes. I'm going to show you the big differences between F# and C#. And then hopefully you get an idea of where to continue your exploration. If you have any questions, write them down. Maybe we'll have time at the end, or ask me afterwards. I'm here to talk programming. So I'm David. I am a technical architect at Frende Forsikring. I've been in the business, I think 14 years now. I've written production C# for 10 years. I've also written a bunch of other languages. I have to Google syntax all the time now because they're all blending into each other. My main goal as a technical architect is to make tech leads and developers feel safe in their decisions, like should we use F#. So Frende Forsikring is a Norwegian insurance company, and that sounds deceptively simple to a bunch of people I talk to, at least. But Norwegians own a lot of different things. They own cars, they own houses, they own boats, and they need them insured because they can't easily pay for them if they break. And to insure those, we need a bunch of details to know what we're insuring, but also to run statistics so the pricing gets correct, or else insurance isn't going to work if the insurance company just goes bust suddenly. And Norwegians own more stuff too. They own pets. They have mortgages that they want their partner not to be saddled with if they have an untimely death. They have a pension they want to have safe if they have an accident happen to them. It's Norway. So they have leisure tractors, just like this is my fun tractor. It's not for work. And it's Norway, so a bunch of people have their own small little farms. So they want to insure their crops too. They have work tractors they use on those farms. That's a completely different risk than the leisure tractor, so we got to insure those too. They have milking machines. And they have work accidents that can happen with entirely different risks than the personal accidents. And okay, you probably get the picture now. This is where I'm from. It's a complex business domain. It's also regulatorily complex. There's a bunch of laws to follow. It's insurance. If you go low enough into each product, though, it gets simple. So I think I can speak to most of you with the different levels of complexity here. And with that background out of the way, let's go into F#. We are going to be looking at a bit of history, or we're going to have an intro first, look a bit at history of F#, C#, similar features in the languages. We're going to look at the pitch of F#, and then, oh my God, functional programming! This seems super scary for some reason to a lot of people. I'm going to make you realize it's not that scary. We're going to look at some bugs that can happen in C# and how F# kind of changes that or handles them better. And then we're going to summarize with looking at some other features in F#, some pros and cons, and when to use them. And hopefully you'll end up with some ideas of what you can do tomorrow to look for places where maybe F# fits or it doesn't fit. Sound good? A little bit of nodding. One yes. This is Norway. Great. So let's look at the history of these two languages. There's not a lot of details here. This is not a very good history. The only reason I want to pull this up is to show you that the base ideas of these two languages isn't very new. So C# is very inspired by C++. We all know that is new. We all know that's like C is like, oh, the syntax. We all know that. F#, I feel like people are often like, what is the syntax? This is crazy new functional stuff. It's not crazy new. It might be a little It might feel unusual, but it's not crazy new. It's 40 years old, just like C++. There are some similar, I'd call them fancy features in C# and F#, and we're not going to look at those because they're the same. US C# developers probably know all of them. If you don't, I recommend you to look at them because they're pretty useful and cool, all of them. So here's the pitch for F#. It comes from the website. It's marketed as giving you simplicity and succinctness like Python with correctness, robustness, and performance beyond C# or Java. So who's heard this about F# before? Just like doing like, yeah, a very few amount. Who here has tried F# before and didn't really get into it? A few of you, that's interesting. Who liked F# and has tried it? Like who's trying to indoctrinate their colleagues? Okay, yeah, okay, there we go. That's interesting to know. Let's look at crazy functional programming now! It's a new mindset. I keep hearing that. We gotta really get into this. It's a new mindset. Not really. And F# is far less of a mind twister than Haskell or Elm. It's just static methods and modules instead of methods and classes. So let's look at this. Here we have a class with a name, some data on it, it's a string, and there's a method here. And here we have a thing that holds data like the class does. And here we have like a function thing. It's static, like this is, or no, not like this is, but here it's static. And then we open instead of using. Oh, it's so different. And here we new the pet insurance, and here we do sort of a JSON thing to make this thing. And then we do the static function here on there, and here we do a method call. It's not scary. It's not a new mindset. F# is really kind of nice. You can basically write C# and F# if you want to. So with that out of the way too, let's move on from the intro to some concrete C# bugs. So let's look at invalid states. Here are some C# types describing a camper van insurance. We need the registration number because we need to know what the heck we're insuring. We also need two types. We also have two types of coverages that a customer can choose between: a liability insurance that insures them for whatever they crash into or whoever they crash into, and they can choose an extra coverage, also often called casco coverage in Europe for unknown reasons. That'll cover them for their own vehicle when they crash into stuff. Pretty practical that way. This seems pretty nicely modeled. I can't really see any bugs here. However, our customers want better insurance, and we deliver them with a new super coverage. So here we have a super coverage. It's a new enum variant, and we have a new data field that's called movables, where they can tell us how much the movables in their camper van is worth, because they want to insure their microwave and their fancy cooking equipment that they have in their camper van. Make sense? Yeah, a little bit. Okay, does anyone see a potential for a bug here? There's some nodding. Anyone want to? Yeah?
You could theoretically have movables, but not with a super.
Yeah.
I'm not sure if I understood the exact problem here.
Yeah, totally. So I should have explained that better, but yeah, you managed to bridge the gap there well. So we don't want a customer to have a liability coverage. They're basically saying, I don't give a crap about the camper van I'm driving, but they're like, I have a lot of expensive stuff in here. That's going to be risky. That's going to be a weird customer. That's a weird proposition. We don't really want that. We just want the super coverage, and then you can have the movables. Then we can price that nice and easy. But here we can have a situation where someone can have set movables and liability. Like, let's say we didn't do the validation correctly in our web shop, and people are just like running through, movables, 1 million. I have all my fur coats in my camper van. Oh no, it burned down. We could add a nullable field to this to try and describe it better. We could add a comment to try and describe better that this should only be set when the other one is set, when super is set. Or maybe, if only there existed a language that could make it impossible to represent this state and eliminate this class of bugs. Oh wait, it does, there does. It's called F#. So this immediately looks pretty similar. It's an F-sharp record, much like C-sharp records, but even more limited, so it's just data and possibly methods, no fancy fields. It stores a registration number and our coverage, and if you look at the coverage enum, it gets more interesting. This is what F-sharp calls a discriminated union. I just call it a fancy enum where a variant can hold data if it wants to. So our super variant here holds a super coverage details record, which holds our movables. So now this is interesting. We can't possibly construct a camper insurance with a liability or extra coverage that also has movables. Some call this tightness-driven development or making invalid states unrepresentable. I say it solves a lot of invalid state problems. On to the next bug, unhandled return values. So this one has a lot of answers of how to do it in C#, multiple return values. A classic one is validation. We're going to look at using exceptions here. Not the greatest way to handle this, but it is a common one. I see it a bunch. And we will look at tuples later too, for you tuple fans. Can anyone see the bug potential here in this code? So I've seen this been done, and I've done this. I shouldn't say I've seen it. It sounds like I haven't done it. I've made a thing like this, and then you have to remember to try catch this exception to actually give this error where it belongs, probably to a customer. But if you don't try catch this, then those exceptions will just bubble on up, disappear away. F# handles this with a match with pattern matching statement that we have here. So here we are matching our result from our try-parse registration number function, just like a switch statement, switch expression in C#. And here we can match on our discriminated union that our try-parse reg number function is returning now, that can actually hold data again in the success. So we're building on what we did on the last bug, and here we can then just match on that, and that's kind of what we have to do too. We have to match on this to deal with the result from this, which ensures that when people are calling this function, they're going to see, oh yeah, right, these errors can happen. And this is actually such a normal pattern in F# that the standard library provides a type for this. It's called the result type. The result type takes two generic type parameters, A and E, and either has the variant of OK with some certain type, like a registration number, or error return, or error variant with error type, like a string. So here I've just used the result type to wrap our now simpler reg number error type, or enum. So it's wrapped in the error variant, and the actual value is wrapped in the OK. So this is more composition than inheritance, which F# likes. We're just wrapping certain values inside certain values, which works really well when your enum variants can hold data. And then here in the match, we match on our two types of errors and on our OK. And if we wanted to just prototype quickly here, we could just match on all the errors the same way and then handle all the individual errors later. All right, let's look at our last example from C# compared to F# here. That's a little small, but I think we can all of you read that? Yes? All right, cool. So here we're doing validations, and here we have an issue where we are making a validations list. We are parsing our reg number, and we are getting out a potential registration number value here, and we are getting out a list of validation errors, and we are appending it to our validations list, because we want to have a bunch of validations to give out to our customer in that, oh, you filled this one out correctly, this one wrong, this one's also wrong, and this one's wrong in two ways. You got to fix these couple of things first. And here we have forgotten to add the second validation array to our validations list, which would give a warning of an unused variable. So this isn't a very likely bug, but I have seen the bug happened before. And I really want to show this because the F-sharp way of solving this is downright elegant. It is using the let, bang, and bang keywords in F-sharp to let us just thread the error values through this computation expression, as F-sharp calls it, transparently. So here we can just say, oh, give us a reg number, give us the brand, and when we got that, put that in a record so we can send that out. And if there are errors from the parse reg number and parse brand function, and they're just using the normal result type that we looked at earlier, they'll get appended and we'll get a nice array of our errors or the actual value out without having to deal with doing this adding the whole time that we can mess up, or it's just noise that we have to look at. And this isn't really even built into the language, which could get constraining, kind of like the null coalesce operator and stuff in C#. This is the code that you need to make this work. The and bang and let bang operators are kind of configurable by you. So you can make the validation work correctly for your domain, whatever that is. You could probably even use this for some interesting applications in graphics. It's 18 lines of code, and then we have our domain-specific validation that appends transparently all our errors, so we get a nice error list out that we can't forget to append to. So let's move on to our summary. We're going really fast. 20 minutes is not a lot of time. Piping is a really cool feature. We don't really have time to look at it, but let's look at summing these insurance prices. We can really quickly have this cool little pipe that looks like link, but this again isn't a very specific feature. It's actually just function applications. It's just a function in F#. It's so cool. It's so easy to teach other people how to do this, and it's completely generic. There's a bunch of other features in F#, which I might not think provide as much value as these other features I've shown you. So some warts, but I mean, how many people here know that C# has goto? C# does actually have goto. Yeah, a bunch of you know every language has warts. We're just going to jump over that. So we are going to end by looking at 3 pros of F#. It has tighter syntax. You might have seen that compared next to each other. There are fewer lines of F# for the C# for the equivalent amount of code. I think that's usually good, but at some point code can get too concise too, of course. It has obvious solutions to domain modeling, and that I think is really important because it's harder to just like mess up and choose the wrong solution to something. And it has less special case language features, like let's say null coalesce in C#, which only works with nulls. In F#, you can pretty much use all the built-in features in a very natural, easy-to-use, generic way. 3 cons. F# is not a silver bullet. It has bigger syntax, I think, because it has significant white space, like Python. And suddenly, everything in your editor is red, and you just have to go through and add some spaces, and the editor is just like, oh, okay, that's fine. You remove one space, and it's like, no, it's wrong. It's super annoying. It is, I think, a downside compared to C#. It has a smaller ecosystem, definitely. And I think if you come from Java, like .NET already feels a little small. F# is even smaller than that again, and the standard library is also kind of small. I think F# makes more sense to use if your team writes tests. That's something to think about. If you have a complex domain, and if your team is good at programming languages, F# is also a better choice than if not. And also you might be thinking, well, C# might get all these features. Then I don't need F#. And yeah, it might get all the features, but C# will get even larger, and it's already pretty large. Conformity will be even harder than it already is. It'll be harder to choose the obvious and good solution to problems. And its ecosystem will be even more fragmented than it is now, with libraries that don't support nulls, or not nulls, but proper null tracking. 5 things to look out for in your C#: variance of structured data, multiple return times, awkward validation, DLLs, or other. I don't have time. But hopefully you can look for that tomorrow at work. Maybe F# will fit you. Thank you for your time.